Good morning. Today's lecture, we will discuss some applications, or one of the applications on AC system, which is the U.S. residential electrical system. So the electrical system, as we know, is an AC. And the electrical system as well, or as far as we know, that it is AC 120 volts, 60 hertz. And some of you might hear that there is another voltage which is 240. So today's lecture we will discuss how this electricity connection will go to, or what's the electrical system will go to the residential, to your home. So most likely there will be 3 conductors feeding your house or your apartment, so it comes from the utility. So most likely these conductors, sometimes the conductors will make them like, or draw them like this. We have 3 positive or 3 live and 1 neutral. So we call it A, which is, this one will be live or positive. We have a neutral, which is the returning current, negative. And we have B, which is another one, it's live. So live, neutral, and live. And neutral is for the returning currents. So here, most likely, the voltage between A and N, or the live and neutral, is 120 volts. The voltage between B and N is 120 volts, actually. And if we want to make sum between them, so if we add them together, or if I connect between A and B, the voltage will be 240 volts. So which is their sum. So it's depending on the connection. If I'm connecting between A and neutral, 120, B and neutral, 120, and A and B will be 240. So we see that we have A and B, which is, we call it lives, or call it 2 insulated, A and B. This for supplying. Or coming from the source. So it can be considered as the source. While the bar wire, or the neutral, this one for the returning currents. Why do we need a returning current? Because we need a completed circuit. If we only supply the live without a neutral, so how can we get a completed circuits? So in order to let the currents flow, we need a completed circuit. So we need coming and returning. That's why we have a neutral. Okay, so the standard voltage is 120 volts or 240. So if between voltage A and N will be 120, B and N 120, while if I need 240 will be between 240, or between A and B. Okay, so someone can say, why do we have 120 and 240? Why don't we use 120? And say, okay, that's the system working. Because the actual there is some applications that need higher power. We know that the power equals V times I conjugates. So how can I know, like, I'm consuming a certain amount of power? By looking at the current, if the voltage is constant. Sometimes I need higher rates power, so I need higher voltage as well. So for example, when we have the AC unit air conditioner, this is 240, or your dryer, 240. And some applications are based on that. Sometimes the heat, the water heater, it's depending on the heater type. So 240. While some applications, like the lighting, 120. And the utility wall plugs, all of the wall plugs are 120. Some kitchen applicants, 120. So it's depending on the application. If we need higher power, then we use 240. Okay, and there is also a ground bar or a ground bus. So that ground is used for protection. That's why sometimes when we look at the utility block, we will see 3 spots. So most likely the first 2 are the working spots, which is one of them for live, the other for neutral, or for phase A or B to neutral, while then the other phase or the other third point, which is for the protection or for the ground. And this exists in case if there is any short circuit happening, if there is any high currents happening, there's something wrong with your equipment, then the current will flow to the ground, to the third spots. The extra or the high currents will flow there. And there is a protection system, so if there is any high current flowing to this ground, the circuit breaker will trip. So you will not get shocked. So if someone say like, if I don't want to use the ground, if I will have 2 spots, will this work? Yes, like in your cell phone charger. Some cell phone chargers have only positive and negative. And cell phone chargers have small amount of power, so it can be safe to use too. Okay, so when the system, we want to connect the system or the, the 3 conductors, they will reach or go to your house. We have something before that, some device that can be in the electrical, the electricity, the electrical utility parts. This device is called transformer. So this transformer is usually targeted step down the voltage. We will discuss the transformer later in this course, but what you need to know is just like the transformer step down the voltage, such that the voltage here that we have from the utility side is 7,200 volts or 7.2 kilovolts. Here is, for example, phase, or you can call it live, and here is neutral. So positive and negative. So what does the transformer do? This one is in utility side. The transformer is converting the power from high voltage, 7.2 kilovolts. This is very high voltage, and this your home couldn't handle this high voltage, and your devices as well. So we need to convert it to lower level. So what's basically doing this, converts to lower value, which is here plus minus 120, here plus minus 120 volts, and all of the values are RMS, just for your information. And here, phase A, here is neutral, phase B. And the neutral is in the middle. So this point, this point we call it center tap. That's why this kind of transformer is called center tap transformer. So it's converting 2 voltages, 120, 120. And if we want to connect between phase A and B, so it will be 240 volts RMS. So basically, these 3 conductors will go to your home. So here is home side. So if you monitor these 3 conductors before going to your home, they will be in the transformer. Then they will be on a utility side. So that utility side comes from transmission lines, which is high power lines, high voltage or medium voltage power lines. So power lines first, then from power lines to the transformer, then from that transformer to your home. Sometimes this transformer can supply more than one home. It's not necessary like there should be one transformer each home. Sometimes it can supply a neighborhood. Okay, so here is power lines, transformer, then here it will go to home site or the residential area, these three conductors that we talked about. So the first point, when these three conductors reach your home, what's the first point we'll reach? The meter. After the meters, what do you think?
Circuit breakers.
Circuit breakers, right. So it will reach a circuit breaker panel. And circuit breaker, you might be familiar with this, which is similar to this picture. So what's the circuit breaker and why we are using it? Circuit breaker is basically for connecting and disconnecting the circuits. Why we are using it? The circuit breaker for protection. And when we are doing some kind of maintenance, the circuit breaker also trip the circuit breaker, disconnect all of the powers from your home, do your maintenance, then reconnect your home. This is not only, this is also for protection. If there's something wrong in your system, the circuit breaker should deal with it. Let me assume that at your home, the V is constant. The voltage is constant, which is 120 volts or 240. And the loads in your home most likely are connected on series or parallel. What do you think? Parallel. Because the voltage is constant, 120. When we go to the utility wall plugs, 120. Go to the applicants, 120. So all of them 120. This means all of the loads are connected in parallel. So let's assume this one, for example, the refrigerator. This one, the lighting. This load, kitchen. And let's assume that if there's something wrong happening, one of the kitchen applicants, which means short circuit happening. So short circuits happening at the kitchen, which means the current will flow here, will not flow to these applicants. What does this mean for the rest of the load? Which means all of the currents will flow here. There will be short circuit for the rest. So what will happen? The current will flow here. And we know that V equal to I times Z. I times Z. V is constant, so I will be V divided by Z. So at short circuits, Z will be 0. So it will be V bar divided by 0. So, and according to mathematics, any number over 0 is what? Infinity. I equal infinity. But infinity ampere. But is there something exists like infinity? No. So here in electrical engineering, or in engineering in general, we defined infinity as a very large number. So very large currents. That's what does mean. So here, infinity is just expressing or indication that a very large current will flow. So what's happening when a very large current flow? If there is no protection, what will happen?
Will overheat.
Yeah, will overheat, will ruin all of the wires in your home, and this also can be danger. In your home can be danger, and the people inside the home. So if anybody touch any electrical utility parts without clearing that short circuits, he will get shot, and all of the equipments will be affected. So in order to do this protection, or to protect your home, protect your devices, there will be a circuit breaker. So circuit breaker is detecting high currents. Circuit breaker detecting high currents. So if there is high currents happening, this means there's something wrong, then the circuit breaker will trip. So the circuit breaker will trip when there is a short circuit happening or when there is an overload. Let's assume that you need to run a large amount of power that your residential system couldn't handle. So the circuit breaker will trip to let you there's an overload. So there are many uses for the circuit breaker, and it's essential part. It must exist. So circuit breaker, sometimes I donated it by CB, will trip for high currents. And it's detecting the high currents in milliseconds. So if there's a high, for example, the currents exceeded 35 amperes or 50 amperes within 1 or let me say like 5 milliseconds, then it will trip. So within milliseconds, it should trip, and it should take this action to avoid like something, to avoid the damage happening. Okay. Now, we know that, let me go back, sorry, for the panel. When we look at this panel, these are the circuit breakers here. When you look at the circuit breakers, most likely at your residential home, you will see some, like read the label. It will tell you, for example, this circuit breaker for bedroom lighting, for kitchen lighting, this one for example, home or kitchen applicants, this one for refrigerator, etc. And it's most likely recommended, or that's what's according to the standards, the lighting circuit breaker should be different than the wall plug circuit breaker. Because if there is something wrong happening at your devices that connected to the wall plug will trip, not your lights will trip. And most likely as well, the lighting circuit breaker, since the lights are not consuming high power or high energy, then the light circuit breaker will has lower ratings. So it can trip at, for example, 30 amperes, while the utility or the wall plug will disconnect at 35 amperes. So the wall plug is assumed to consume energy more than the lights. And when you look at the circuit breaker, you will see like these are individuals, one circuit breaker, which means 120 volts. Let's look at this. Here we have two at this part. So what does this mean? 120, 120, 240. So this means it's for 240 volts. And when you look at your circuit breaker, I encourage you to look at your apartment or your home, look at the circuit breaker panel, and you will see that these two is connected for some devices that need higher energy. For example, you will see that in these two connected to the dryer. And these two, for example, also 240 connected to the air conditioning units. So it's depending on the application. What about this 3? This one has 3. So the meaning of 3, which means A, neutral, and B. So this means this is the main circuit breaker. So the main circuit breaker exists as a backup protection. If we assume that there is a failure, one of the circuit breaker didn't disconnect, then the main circuit breaker will disconnect after that. So we can make, so we call it a protection coordination, such that if there is high current flowing during 3 milliseconds, this circuit breaker should trip. If this one failed to trip, and this high current continues for another 3 milliseconds, then the main circuit breaker should trip. So it's just as a backup. Or in case if you want to make some maintenance and you disconnect everything in your home, disconnect the main circuit breaker. Okay, is that clear? Good. Now, here the connection panel says that we have 3 conductors, A and B and neutral, comes from the transformer to your residential home. And A and B, this can be, we can connect A to neutral, B to neutral, or A and B. And we have a main breaker that I told you, the main circuit breaker. Then it will go to the other circuit breakers or individual circuit breakers, depending on the applications. So here is this panel again. But here there are some justifications that it says here is the three conductors, and the first point it enters the meters, the wire meters. After that, the main circuit breaker, then it will go to the rest of breakers. Some devices or some panels, they have the main circuit breaker here. Some panels here. It's depending on like the panel itself. So then you will see phase A, phase B, and when we see a connection between A and B, then it will be A to B, which is 240. When there is A and a neutral, which will be 120, and so on. Okay, any questions? Okay, so now I talked about the circuit breakers, and I said it will be tripped at high currents. So what's wrong with flowing high currents? What will happen if there is high current flowing?
Breaker will trip.
Yes, the circuit breaker will trip. I mean, if the circuit breaker didn't trip, what will happen? Why we put the circuit breaker? To avoid high currents. What's the high currents causes?
It can cause a fire.
It can cause a fire. Why?
To overheat.
Overheats, right. So why there is overheats?
Because of resistance in the wires.
Yes. Let's talk about this. So we know S bar equal to V times I conjugate. Okay? So here, V is constant. So as S increases, as I increases. Then, when I increases, or when there is a short circuit happening, I increases, this will make limitation goes to the electrical or to the system happening. So we know that the resistance of the wire, rho L divided by A. So L or divided by sigma times A. And we know the losses will be I squared times R. So the losses goes as heat. The energy does not the energy should transfer from one form to other form. So when the energy goes to the wire and the losses goes to the wire, then they just go for nothing. They will go as heats. So when there is a high current flowing, there will be some heats. So that's why we see some heats, because the energy will transform from the electricity to the heats. So this means that every wire has its capacity, current capacity. Has a current capacity limit. Why? Because the currents will flow, will cause some heat. So at a certain temperature, the wire will get failure. And the wire insulation will get also affected. So at a higher or at a certain temperature, it will get failure. It's depending on how much heat do we have. And let's look at the wire or the resistance, L over sigma times A. If the cross-section area is higher, the resistance will get lower. If cross-section area higher, then R wire lower. And what's happening? Loss is lower. which means if the cross-section area is higher, then current capacity
higher.
I have a question.
Yes.
Is the theta, how did you, if you go up to the equation,
Here?
there was, is P equal to 1 over sigma?
Right. Rho is resistivity,
Right.
and sigma is conductivity. I assume this one is familiar from physics. And I already explained this,
I think,
at the first lecture.
on AC circuits.
Okay, so if I increase the cross-section area, the current capacity will get high. So the higher thickness of the wire, the higher current capacity. This is the point. This is the conclusion
That I need to understand.
So, and I explained all of this just to let you understand. I can say that by increasing the thickness of the wire, by increasing the current capacity, but I want you to understand what's happening. Because I want everyone to ask why. Don't take the information
As is.
Just ask yourself why this is happening. So, according to the standards in electrical engineering, we have something we call AWG, depending on the wire standards. So we have, for example, AWG 12, AWG 14, AWG 20, and so on. So for example, AWG 12, it can handle 20 amperes. AWG, for example, 10 can handle 30 amperes. And AWG 14, it can, I'm not exactly sure, but it's below that, less than 20, of course. So based on that, the highest AWG number is the lowest thickness and lowest something we call it ampere capacity, amps capacity. So you can Google it, write in Google AWG 10 or AWG 12 ampere capacity. It will let you know there's a chart according to the standards. So it's depending on the application. We can see like, oh, we need AWG 12, we need AWG 10, AWG 20, and so on. So these wires are standards according to the ampere capacity. And the smallest number gives the highest capacity. Now let's go back to the notes. So we have 120 volt circuit breakers and 240 volt circuit breakers. Most likely for 120 volts, we are using AWG 14 and AWG 12. So we have breakers 15 amperes and 20 amperes. Why do we have two types? Because depending on the application. For example, 15 amperes and AWG 14 are used for lighting. That's consuming smaller power. While AWG 12, or which needs 20 amperes, this most likely are used for applications, like kitchen applicants, anything applications, or the utility, or the wall plugs. The wall plugs, AWG 12. And how about 240 circuit breakers? 240 circuit breakers, we have sometimes they are using 30 amperes or 50 amperes, and typically AWG 10 or 8 or 6, depending on the application. And here we are, this one, for example, in AC air conditioning units, or in dryer, for example. And the smaller wire number, or AWG number, the larger ampere capacity. So AWG 14 can handle 15 amperes, 12, 20, and 10, 30, and I think 6, 50. You don't need to memorize all of this. I just want you to understand that the highest number, the lowest capacity, and vice versa. Okay, clear? Let's see this example for quick. Determine all of the currents at home that has the following. 240 volts, we have air condition units connected to circuit breaker 1 and 3, and absorbs 5 kilovolts ampere at 80.8 lagging power factor. Heater, consuming 4 kilowatts, and we have a load here 4 kilovolts ampere with 0.9 volts. Now, let's look at this. The power given as 5 kilovolts ampere and 0.8. Sorry, it's not clear. 0.8 lagging power factor. So we need, from the power factor, we can find the angle theta, which is cosine inverse of 0.8, and it's positive because lagging power factor. So it will be 36.87 degrees. Then S load will be 5 times 10 power 3, angle 36.87. This is the first S. The second S for this one, S load 2 equal 4 kilowatts, 4 times 10 power 3. There is no imaginary part, so SL3, it will be 4 kilovolts ampere, 4 times 10 power 3, angle cosine inverse of 0.9. And it is positive because it's lagging. Then it will be 4 times 10 power 3, angle cosine inverse 0.9, which is 25.84 degrees. So I want everyone to make sure that look at the information, and you need to get to know how to get the complex number from the available information or the given information. So in summary, here are the procedures. This is how we find S load, how would you find it, and convert it to rectangular. This is S load 2, this is S load 3. Then add them together to get this. So after that, we need to determine the currents. How can we find the currents? By saying S equal V times I conjugate. Then I conjugates will be S over V, or I will be S over V over all conjugates. How can I find the currents? I can say that IAN will be SAN divided by VAN over all conjugates. SAN is given and VAN is given as well. IBN will be SBN divided by VBN, and they are all conjugates. ICN will be SCN, IAB will be SAB divided by VAB over all conjugates. So I don't want to substitute these numbers, but I just want you to understand the procedure. This is how we find the currents. After that, we need to find IA, IN, IB. We can apply KCL here. By applying KCL, it will be IA will be IAN plus IAB. How about IB? IB will be, let me make it clear. I'm sorry for the inconvenience. IB will be negative IB, negative IAB minus
IAB.
Just applying KCL. And I neutral will be IAN minus IB. So it's just like calculation. Calculate I, S over V conjugates. This for can be applied for A and B and AB. Then here we can find IA and IB and IAB, and find IA, IB, IC by applying KCL.
Can you see the second equation?
Here, here,
What does that say?
which one here?
Yeah, no, you were
Here?
right.
Okay.
No, you were right. Go up. Does that say IAB minus IAB?
IAB minus IAB. I'm sorry, IA and minus I. I think IB. IA minus I. Okay. So for more information, you can look to the completed notes. I think it will have the detailed answers. Okay, and if you struggle with this, just email me. And if you want me to re-explain, I can explain in the next lecture after the break. So.